I'm going to go ahead and jump into our presentation. I do apologize for you folks that missed the start of this because of the snafu that we had there. So with that, I am going to share my screen. And we're going to start off. I have a presentation to go through. Gives you some background on who we are and what we do, and then we're going to do a deep dive on QA and end-to-end testing for Alexa and Google Assistant. So with that, what we're going to go through some introductions, talk about what we do, talk about testing and monitoring and the general ideas behind it, discuss end-to-end testing in depth. We're also just going to touch upon continuous testing and then leave some time for questions at the end. And we may go slightly over today. I understand if some of you guys have to jump off. Obviously, feel free to ask us questions afterwards if you don't have time to ask them as part of the session. In addition, we do try to make this somewhat interactive. So if you have questions as I'm going through it, we will take a look at those and they'll be sent to me over. I'm actually looking at my phone simultaneous to this. So I'll take a look at those questions and try to answer them as we go through. So just a few introductions. I'm John Kelvie. I'm the founder and CEO of Bespoken. I'm joined on this by Bo Schrader, who's our head of marketing, as well as Ivan Perez and Fiorella Casavilca, who are part of our customer success team. And what do we do as Bespoken? Well, we provide monitoring and testing tools for voice apps. We're a recognized vendor of Amazon and Google. We have over 1,000 apps that we monitor, as well as more than 3,000 developers that are using our tools. And we have a long history with speech recognition and AI. And on that last point, my background is actually building a speech recognition system. I did this at scale, and as part of building that, I probably spent my estimate for it is about 5% of our time was on coding it, and 95% of the time was spent on testing it. That's not because we're really bad coders or developers. It's that when you're working with something that's based on speech recognition, that's based on AI technology, you cannot look at things or fix things in isolation. If you're making changes to your interaction model, if you're making changes to the behavior of speech recognition, side effects are sort of invariable or unavoidable. And it's really important that you be constantly testing and optimizing for any changes that you do make. So that experience that we had with that really informs what we do now as Bespoken. We're not providing the AI technology. Amazon and Google are nice enough to do that. But we are still trying to deliver great experiences for users and great applications. And so that sort of background that we have there, we find to be very helpful in doing that. So with that, an overview of what testing and monitoring is. What you see on the left-hand side here, we have some general statistics about Alexa and voice. Many of you may be familiar with this, but in particular, one I would highlight, for issues that you catch them in design, they're 100 times less expensive than if you catch them during production. So it's really helpful to get things, to identify any bugs or issues early in the process. It certainly saves you a lot of money and time. In addition to that, we like to think about testing on the right-hand side as this 4-layer cake. At the top, there's manual testing, and that's really just making sure the basics of your skill or app are working correctly. Below that, there's automated unit testing. And this is really about ensuring that your code is correct, and the code in isolation from the system as a whole. End-to-end testing, this is the other side of automated unit testing. This is making sure that the unit test, that the system as a whole is working correctly, not just the code. So you're looking at Alexa, you're looking at other dependent pieces there. And then finally, continuous testing, which is about monitoring your system on an ongoing basis and making sure that it's working correctly. Once it's live there. So a bit more detail on this. Manual testing, I think this is familiar to almost everyone. If you have an Alexa device, if you have a Google Home device and you use that to interact, you're doing manual testing. One thing I would highlight that we offer here is we testing that can be done locally without deployments. We do that using the same technology that we use for our unit testing. If you're looking to test a skill or an action without having to do any sort of deployment, without having to set up your interaction model in the Alexa console, you can do that using our tools, which is a nice boon for manual testing. From there, that's really what we see as just a starting point. You should really be doing automated unit testing. And this is really about testing your code in isolation and ensuring that it's working correctly. We've done other webinars focused on that. We'll do them again. We're very pleased about what we offer here. The idea is that you set up your unit tests, concurrently to actually writing your code. You can run them all locally on your laptop, on your development device, no deployments, no setting up of the interaction model and the skill console. Instead, you can be running it all immediately right there on your laptop. This allows you to debug things much faster. It also means that once you have your unit tests set up, you can use them on an ongoing basis. And so you can quickly actually hook them into continuous integration systems. You can hook it into code coverage. These are all tools that are quite easy to set up once you have your unit tests written, and give you not just this big boon when you're doing your initial development and debugging, but then on an ongoing basis, you're rerunning those tests and you're making sure that everything is still working correctly. So then you get this ongoing benefit by having done this relatively modest investment during your initial development. I would also just mention that we're very pleased now that we're part of the Alexa tutorials. You can take a look at the skill sample Node.js fact for how we've set up our unit tests and how Amazon has included us in their projects. So end-to-end testing, I'm going to go into a lot more depth on this, but this is the other side of unit testing. Instead of just testing the code, here you're really looking at the system as a whole. And so you do have to do a deployment. You have to set up your interaction model and configure your skill in the Alexa console with your Google action. The benefit that you get by doing this is that then you can test the entirety of the system. So you can be testing the speech recognition, testing the NLU, testing the behavior of your skill and any dependencies. All of this is happening as part of an end-to-end test. So it's really, there's a lot more setup that's involved and there's more configuration, but then it's giving you this extra level of depth and security, especially as it relates to the AI and speech recognition. We're going to go into more depth on that, but just quickly, we also offer continuous testing. This leverages the same pieces we use for end-to-end testing. It is actually interacting with the Alexa platform itself. It's as if someone is speaking to Alexa, and what we're going to do is we actually run these tests on a regular basis every 30 minutes. If it works, great. We'll send you a weekly summary telling you what happened and how well it's been running. If something doesn't work, you'll get a different sort of email. You'll get a notification saying that there was a problem, such as what you see on the right-hand side here. Very easy to set up and configure, and gives you this extra layer of security. All right, so before we just jump into some demos, overall, we have this sort of call to action for everyone who is thinking about doing automated testing. And our call to action for why you should do this is that automated testing, we believe that it's a superpower. And the reason why we say that is that if you take advantage of automated testing and monitoring, it's going to allow you to troubleshoot problems much faster. In the way that I mentioned before, you can do everything locally on your laptop. You're not doing deployments. You can set up complex sequences of steps that you can quickly run through and instantaneously get to a particular point, a particular state within your skill or your app. If you're doing that manually, interacting with the device, if there's some sequence where a bug happens 5 levels deep, that's extremely error prone. You're very likely to end up, misspeaking in some way. The state doesn't get set quite right. All these things can be controlled with unit tests. They allow you to develop much, much faster. And I think even saying that it can make you into a 10x developer is perhaps understating the sort of gain that you can get from it. At the same time, if we're talking about on the QA side, manually going through and actually testing all these scenarios, even for a skill that's just in one language, is quite tedious. You can have hundreds, if not thousands, of utterances to go through in a single language. And then if you layer on that, okay, let's test different genders, let's test different accents, that becomes even more difficult, if not impossible. Even further, if you add on... Hi guys, sorry about that again. Normally we don't have these many technical difficulties. We might need to look at a different webinar platform, but hopefully you can hear me again. So I had just completed going through those slides. That was not meant to be a seg to going into demonstration, but we are now. I did want to go through the actual end-to-end testing and how to set up these scripts. So that, I'm going to share my screen again. Okay, so first of all, what does an end-to-end testing script look like? This is a simple one that we set up. This is for a skill called Bring. Bring is basically a grocery list app. It allows you to add items to a list, get the list of items, and remove items from it. So very straightforward. We picked on this for sample tests because we think it's easy to demonstrate and understand. It's also in multiple languages, which we think is also handy. So to do a basic test with it, very easy. Here's a 2-line one that just launches the skill and tests the response that comes back. The first line is a description. The second line is the interaction itself. And what's happening with this? Well, the left-hand side is what we're going to say to our skill, and the right-hand side is our expected response. And what happens underneath the covers with this is we are actually taking this utterance, open bring, we take that text, we turn it into audio. We use Amazon Poly for that. And you can specify which voice to use. You see that up here with Poly. And so we turn this into audio. We send it to Alexa and I should say also Google Assistant, it works the same way. It in turn is sent to the skill. The skill does whatever is appropriate with it, comes back with a response. That response is also at least partially in audio format. We take that audio, we turn it back into text, and then we compare what we expected to be the response with what was actually the response. And so here's that expected part. So there's a lot that's going on there, but in terms of how you write this as a test, it's very, very straightforward. And I think you can see that here. Now, if we want to get a little bit more complicated, here, we're not just testing that response itself, but we can test other elements of it. So we can test to see what the reprompt is. We can test to see what the card is. In this case, we're expecting that there's not a card. Down here, we've specified more items, and so we can actually define a number of valid expected responses. So when we say that the prompt can be any of these, what it means that if any of these values matches what comes back, then it's accepted. So this is a very common scenario. Having variations in your responses is a good thing. It's a recommended thing for voice apps. And so this is an easy way to support that and test it. And we can also test detailed information about the card content, other display information. There's really a ton of things that we can check there. So now, if we want to go ahead and run this, and I see there's a question there. I'll answer that in just a second. So I'm just going to run our launch request here. I already did install our tools. So if you're getting started with us, you would first type something like npm install bespoken tools-g. This is all in our instructions. So I've already set it up. And so to run it, I just go ahead and I click here. And I'm running this particular test file. Now I could also run all of them at the same time. And while that runs, it doesn't run particularly quickly. It runs about as fast as you can talk to a device. Don't think that it won't scale. You can actually set up the equivalent of many people talking to many devices simultaneously. So it does scale quite well, but running any particular interaction can be a little bit slow. I will also just mention that this project that I'm showing, while that's running, this is all published here. You can download this and get started very quickly with it. All right, and so meanwhile, this test did run. And I see I have the tests and the different interactions within them. One of the tests did fail, and that's the what is on my list. And we expected that to fail because we specified a card title for it, and there actually is no card on the skill. So we did want to show you how to write a test that uses a card, but in this scenario, there's not actually a card there to look at. So it's expected to fail. This is how your failure shows up. It highlights the particular condition that was a problem, which you can do in this case if we wanted to fix it because the skill is not supposed to have a card. We would remove the portion of the test, but just as likely you would go ahead and go in and actually change the behavior of your skill. So sorry with that. I wanted to go back over here. Now there was a question, why do we have this virtual device token here? So just to back up, when you're setting up these sorts of tests, the first step is actually to create a virtual device. And so a virtual device works like a physical device, but it allows us to interact with it via software. So that whole interaction I was talking about, in which we're turning text into audio and then sending it to Alexa, we're sending it as if it's coming from a virtual device, just the same as if it was coming from a physical Echo device or Google Home that I had in the room with me. And this virtual device token, that identifies the unique virtual device that we're using. Now, we put this in this file. We could just as easily have it set up in our overall configuration here. And if we put it into, we have this configuration file testing.json. If you set it up here, it's going to use the same one throughout your tests. If you set it up within a test file, it's going to override that and use a particular virtual device. So that's why we configured it in that way. And when we're interacting with it, to sort of make this concrete, let me go over here. So we can actually see these virtual devices set up here. So just like you'd have an Echo Show listed or an Echo Dot, we have all of our virtual devices listed on this page, and they really do work like regular devices. And we can even go in, just to further that point, we can see this history of our interactions. So for example, we were saying open bring. We can actually listen to that here. Hopefully you guys will be able to hear this. I didn't hear that play, but through this page, we can play back everything that gets said. I'm going to try one more here. I guess my audio is not coming out. But so this history page, besides giving an example of how this works, and showing you how it really is like interacting with a real device. In addition, this is a very useful debugging tool. It's very useful because if you're concerned about any issues with speech recognition, looking at what Alexa thinks that it heard versus what you intended for it to hear, that can help you identify problems with the interaction model, identify areas where you want to improve your utterances or your intent schema. It's very useful here for that. And so we look at this page all the time when we're doing testing and we're trying to actually debug our skills. Similarly, there's the same sort of page for Google. I'm not going to bring that up right now, but you can go through and look at that same history and do the same sort of debugging there. Now, if we go into another language, so here we've set up some tests in German. You'll notice overall we have our project divided into different locales, and then we have tests for each different intent. And that's one of our best practices for configuring these tests. It's the same sort of setup for when it's written in another language. Here's an example of handling many different responses. So here we have different welcome messages coming back when the person opens the app. Any one of these will be considered accepted if that's what the response is. So it's very easy to set up these tests as well. And we've been successful even for languages that we don't speak in setting these up, because we can specify with Poly someone with the correct accent, somebody that's that sort of that speaks that language, and then we can use Google Translate to actually come up with what those inputs are. And we might have to play around with it a little bit if you're not a native speaker in that language. But just through cutting and pasting and working with Google Translate, you can actually set up automated tests in languages that you know nothing about. No one on our team, for example, is a Japanese language speaker, but we actually have a full set of tests written in Japanese to test our own engine, and they all work well. And it was just based on taking English phrases, translating them to Japanese, playing around with a little bit, and we were able to put all that together. That would be impossible if you're actually just trying to talk to the devices. So now if we go here and we want to run these tests, I'm going to run the launch request for German. And we can even look at while it's running, we can see the interactions coming through here. This is our German language account. We have a separate one set up for this, and it's configured for the German skill store. And we actually see the responses came through here as if we were talking to it live. And it should have completed now. It did. And so we see each of the tests, each interaction with the test. And one thing I should mention here is this is as if you're keeping a session open. So you can do many different interactions. So right here we're saying open it, and then we're saying tell us what's on the list. You can keep a long, complex set of interactions going on throughout these tests, which is really, really a nice thing. So you can test, the most complex sort of scenarios within a skill. So this all passed. Again, here we can see what was said and what the expected response was.
Sag mir, was auf meiner Liste ist.
There, it actually started working. Let me play that again at a lower volume. Oh, come on.
Sag mir, was auf meiner Liste ist.
So that's actually what the generated audio sounds like. It is just like a real German speaker. Really helpful in working through these scenarios. With that, I think we touched upon how to do testing in different locales and languages, working with different poly voices, configuring these tests to actually run with Google. You're using exactly the same principles. The difference is, and this is covered in our documentation, but what you're going to do, instead of setting your platform to Alexa, you set your platform to Google. And there's a different process for getting a token. So we described setting up your virtual device here, how to set it up for Alexa, how to set it up for Google. In either case, once you get your virtual device set up, you take the token that's created and you put it into your script. And at that point, it really is, you're just interacting with your device as you normally would, except you're able to type to it, which is, we think, sort of amazing. and makes things much easier. Another thing I would just highlight with this is we do have a programmatic API. This is valuable for some folks that we work with. And so with the programmatic API, you can actually, I should go over here. So we have support for it in Node.js. And so actually interacting with this via code, it's as simple as calling message with whatever you want to say to Alexa or Google Assistant. And so let's say you have some huge number of utterances out there that you want to test, one that you don't actually want to type them all out. Maybe they're just in a flat file somewhere. You can actually go ahead and just write like a for loop, for example, around this, and then send each message to your device, get back your result, do whatever test against it that you want to do. It's very, very easy to work with programmatically. We think our test scripts are even easier, but if you're looking to do something that's more sophisticated, in which you're using lots of utterances or you're doing things somewhat dynamically, this API is really helpful for doing it. And you know, we like to say that people can get started using the virtual devices in an hour. If you're using it programmatically, you can get started, you know, in 2 hours. It's really not much longer. It's not a complex API. You know, overall, the way that we think about this is that once you get past that sort of, you know, the sonic barrier of turning that text into audio, which we've done for you, it becomes very easy to work with this, because at the end of the day, you're really just sending simple utterances. That's the main mechanism for testing. It's a lot easier than, say, if you're trying to test a web page, for example, where there's, you know, sort of an endless array of types of inputs. Automation for voice really is very straightforward once you get through that sonic barrier. All right, so it's 12:55. I did have some other slides I was going to go through. I will try to jump through these pretty quickly. We also offer the continuous testing. I mentioned this early on. This is a simplified version of the test scripts. It's not as powerful, but the idea is that you set up a simple sequence of interaction, and then we run it on a regular basis, and we'll notify you if there's any problems at all. If you're concerned about your skill behaving correctly once it's live, this is a really easy way to get confidence that it's working correctly and there's no issues with it. You can just log into our dashboard. We provide a URL for that in this presentation, and get these set up. I mean, this takes 10 minutes to set up. It's really super easy, and then you can get this extra level of confidence that everything is working correctly. So that just some best practices. We recommend using test scripts during development and QA. We recommend using our monitoring once your app is live. You can run test scripts in addition on a routine basis. So if you come up with really deep set of tests, running them on daily or weekly basis, depending on what your needs are, is another great way to ensure everything is working correctly. And I'll also just mention that we do offer testing as a service. We'll help people set this up. So if that is something that is of interest, please just reach out to us. And in terms of getting started, well, a couple things. We have documentation that we hope is very helpful and very clear. You can just click on this link and it's going to walk you through how to get started with our end-to-end testing. We've also started doing office hours. We're going to hold these on a weekly basis. It's going to be Wednesday, 10 a.m. Pacific, 1 p.m. Eastern, 7 p.m. Berlin. sorry about the late time for folks in Germany. I know we do have a lot of users there. And the idea with those office hours is we want to have a time for people to just come in, ask us anything about automation, about our tools, about Alexa. You can ask us about the weather even if you want. We won't be offended. We'll give you the best answers we can. They're going to be better if you ask those questions about automation. That's our expertise. And to that point, if you want to then get even more in depth, you can set up an appointment with one of our automation experts. It's really not hard to get started with automation. We really do try to emphasize that this is painless getting set up, and once you do, you're going to save yourself an immense amount of time. So if you make an appointment with us, we'll get you going in as little as 30 minutes, and you can start saying goodbye to all that manual testing that you've been doing. So with that, I want to throw things open for questions. I'm going to stop sharing my screen here. So sorry we're a bit pressed for time, with those issues at the beginning, but if you do have questions, I'd love to answer them. I don't see any questions at the moment. I will actually go ahead and ask my own then if people want to respond. Live skill. I guess I didn't even type that in. I could have just said it. But how many of the folks that are on this currently have a live skill? Kevin, yep, I know you guys have a live skill. Balraj, I know you also, and I am aware. Yes, you guys have a very live skill. So I see a question, what if I want to test my action, but it has random data coming from the data file every time? So one, I didn't show this, but we support wildcards within the responses. So if you really have a completely variable response and what's coming back, you can just specify an asterisk there, and that will accept any response. And you can do, if there's some preface to the response and what comes back, you can have, for example, if it's a weather skill, which is close to random, but it always starts off with a preamble like the weather in your city is, XYZ, you can have, say, the weather is, and then wildcard. And so that's a way of testing and ensuring that the skill is still working correctly. If it's truly dynamic, but you want to see that the dynamic responses fall within a certain set, that might be a scenario where you want to take a look at using that programmatic API that I was showing. Because with the programmatic API, any limitations you might run into with the test scripts, you can typically overcome just by interacting with that SDK. And I see a question says, a lot of the slides show Alexa and not Google Assistant. I do apologize for that. That does show our bias towards Alexa. Our Google Assistant support it's something new that we've added, and we still tend to emphasize what we do with Alexa because we've had support for Alexa for, since the end of 2017, and we just added support for Google in the last month and a half. And you'll hear me in talking about things. I tend to err towards saying skill. Our slides still emphasize Alexa, but we do support Google Assistant, and we're eager to help customers on both platforms. And again, one nice thing about the syntax that we have, and I should say about testing voice in general, is that it's really, if your app behaves in the same way across the two platforms, your tests can be essentially identical for the two, because you really are just speaking to it and generating that audio. Yes, you can use the Programmatic API for Google Assistant. It's just a matter of setting that same, what platform are you working with, and you set it to Google instead of Alexa. It's that straightforward. And I see Kevin asked a question, why do we have to train homophones using the new Bespoken tools? So the homophones are a feature that is not as widely known. But I'm just going to share my screen here just to show you guys this. So why do we use homophones? So let's take a look at this scenario here. Let's take a look at something really simple. So we say open Bring, and it replies and says, welcome to Bring. Now, what we get back from the platforms, from Alexa or Google, is an audio payload. And we have to turn that audio then into text. And we use speech to text to do that. That's something that our software does. And it might think that it heard ring. Speech to text is imperfect. And so one of the things we do to make it easy to write, clear, easily understandable tests, you could write this test if it'll tend to, I should say, consistently misunderstand things when it's doing that interpretation. And so you could just change the test so it says welcome to ring. That's what the speech to text tends to hear, even though it's actually saying welcome to Bring. Or you could put a wildcard here, another potential solution. But something that we've added to our software that makes the tests more readable and works around any of that issue is you could say at this homophone, which is if you hear, for the word bring, if you hear any of these words, just assume what was actually said was bring. And so we're underneath the covers in our testing engine. We're just going to go ahead and replace those words with bring and assume that was what was actually said. And so then you can write your test in this very intuitive way. If you haven't used our software at all, this is kind of a second level concern, but it's just a mechanism that we think is easy to set up that allows you to then write tests in a way that's very readable and maintainable and makes sense to anybody that's looking at it. So I hope that answers your question there, Kevin. I see another question. Are there advantages to using the Programmatic API? Here's a case where I would use the Programmatic API. And there may be many of them, but here's one to sort of make it, just sort of crystallize it. Let's say that, let's take the Bring example, a grocery list case. And for the grocery list, I have a slot value of the item that I want to add to my list. And so I might, and I'm concerned about how well it recognizes items in the grocery store. So I might have 1,000 different items that I want to check, but the response for every one is going to be the same. You know, it's going to say, great, we added bananas to your shopping cart. We added, you know, orange juice to your list. In every case, it's coming back with the same response. So how might, I mean, I could go ahead and I could write up each one of those tests in the test file with that response being tested as well. Or I could construct that programmatically where I know whatever is that input, bananas, it's going to come back as I added input to the list. And so that's a great example. I can write that in 5 lines of code, have a flat file with all the slat values I want to test that has 1,000 lines in it, but is, you know, much easier to maintain than 1,000 tests. And then just write a for loop around it. So that's a scenario where the programmatic API can be very useful. You know, so it just depends on what you're trying to do. And so, Kevin, I see yes. Can you explain again how utterances and replies defined in the skill can be used for end-to-end tests? I'm not totally sure how to answer that. Utterances and replies. I mean, what you type in your test, that's the utterance that's sent to the skill. That's what's turned into audio and then sent to the skill. I don't feel like I'm probably answering your question there. So if you maybe could embellish a little bit more, maybe I can answer it better. Okay, so meaning without adopting test scripts all the time. I'll follow up with you on this, but I think I might know what you mean. And so as the behavior changes within the skill, there's not a way to automatically update the tests to accommodate that. So if you're changing the response and all your tests are expecting a certain response and your code has changed it so the response is something different, I don't have an automatic way to handle that. That's just something that, you know, you need to update the test then. Now, if changes are being made all the time to responses, there's ways to construct tests so that they're not fragile, so that they're unlikely to be broken. Because if it's like, you know, you're changing the goodbye, you know, if the user says, I'm done, and your response is changing from goodbye to goodbye and see you later, you know, you could test for just the goodbye, or you could use wildcards. There's some ways to make it more brittle or less fragile, not more fragile. But if you're altogether changing the responses, gee, I don't really have an answer there. I see there's another question. I'm a student right now studying college. I want to know about companies which recruit Alexa developers or Action on Google developers. I'm looking for a company to do an internship. If you send me an email, my contact information is within our slides. If the person who asks that question sends me an email, I'll be, there's not something that pops right into my head, but I'll be happy to follow up on that one. All right, we've gone 12 minutes over. That somewhat makes up for the time that we had lost at the beginning. I'll leave it open for a minute more here, just in case there's any more questions, but really appreciate you guys joining us and bearing with us, and hope this was really helpful. And also, you'll see shortly that we'll have that link for the office hours. So if you have a chance after this session to try out the end-to-end testing, if you have any questions for us, you can set up an appointment with us, or you can come to that office hours. We'll keep the time open to answer any questions similar to what we're doing right now. All right, guys. Well, thank you. We appreciate you joining us. Appreciate the great questions, and look forward to helping everyone do some great testing and automation for voice.